Okay. So, what we're going to do, I'll admit I'm a little biased. This was one of my favorite things when I was your age and I was learning trigonometry. The idea of simplifying equations and trying to make something new out of it. I guess I thought it was cool how sometimes I could get some really difficult equations, but then just by simplifying, you could get it down to be equal to 1 or equal to 0, something like that. So we're just going to spend a little bit of time doing that. So that's this bottom one down here. And then tomorrow what we'll do is we will finish section 2. And then Thursday we are going to Thursday we're going to get into the really the big thing then of trigonometry, which is when we start solving for missing sides and then missing angles in triangles. So basically what we're going to be doing for today is we're just going to be given equations, and it's going to say that we have to prove, and I don't want you to be scared by that. This is not going to be like any of the geometry proofs where we had to do 2 columns and then we had to do, our statements and reasons. That's not I'm getting lazy. So this is not what we are going to be doing. Instead, basically, we just need to take the equation and we're just going to be picking one side, and we just have to demonstrate then that we can turn one side of the equation into the other side. So we are supposed to think of what are the trig functions equal to, and we want to try to turn them into an alternate form and then hope that that will cause them to simplify. So for the first one, we're going to start with, what is cosecant equal to? Does anybody remember that?
Is that sine?
Yeah, be more. It's related to sine, but be
1
more
over
specific.
sine?
1 over, yeah.
1 over sine. That's what yeah, there we go. So cosecant, we're going to turn cosecant into 1 over sine. Then the second thing is we need to figure out what is tangent equal to. So does anybody remember an alternate form for tangent?
One over. Oh wait, no. Yeah. 1 over that one thing. You know what I'm talking about? 1 over. I don't know what it's called.
I know what you're talking. I know what you're talking about, but do you know what you're talking about?
I do, but I don't know the word.
It's one of the 6.
Is it cotangent?
Yeah, there you go. Okay, so we can rewrite this as cotangent. Now, one thing, don't write this down yet. Don't write it down. Can we simplify this at all? Is there anything that's going to cancel?
No.
No, it doesn't look like we're going to be able to cancel anything. So while Aiden is correct, tangent is 1 over cotangent, I'm going to say that we don't want to use that fraction. We want to use a different thing that tangent is equal to. So it's 2 of the other trig ratios divided will also be the same thing as tangent.
Sine over cosine?
There we go. That's what I'm looking for. And now that we write this out, I'm going to keep the right side the same. Now we can see that over on the left side, something's going to cancel. We can get rid of sine of theta on the top and bottom. And now over on the left side, we will have 1 over cosine of theta equals secant of theta. Are those equal to each other?
Yeah. Yeah.
You don't sound very confident.
Yeah.
Okay. Yes. 1 over cosine is indeed going to be equal to secant. So we were able to show that the left side and the right side are indeed equal. So this is the type of proof that we're going to do, is we're just going to be manipulating one side of the equation to show that it can become the other. One thing also, I know that some people prefer to be changing both sides at the same time. There's nothing wrong with that. It's just that I know that typically when we do a type of proof like this, generally we want to try to stay with one side and change it, and then the other side does not change. But honestly, I'm not going to be that picky. As long as you do valid mathematical substitutions, I'm not going to care the exact order that you do them. And honestly, for a lot of these questions, there are multiple ways of doing them, or at least multiple orders. So don't feel like you need to do it one single way. Just because like maybe an answer key, or maybe I show you one single way. Don't assume that's the only way to do it. Okay, what I want you to do for this then, I'm going to give you maybe a minute or 2 minutes. You have cotangent times sine, and you are supposed to demonstrate that that will be equal to cosine. So go ahead, take a little bit of time to see if you can show me how to do that. Okay, I'll give you all about a minute more. Okay, there are going to be a couple different ways that we could do this. I'm just going to show 2 ways, although there certainly are more of them that you could do. So the first one, what is cotangent equal to?
Oh, that's why I messed up.
1 over tangent.
Yeah, so it's going to be 1 over tangent. And then I'm going to keep sine. Oh, it's x. Sorry. Now I'm going to keep sine of x. And I'm going to set it equal to cosine of x. Now, am I able to simplify sine times 1 over tangent? So it's, at least for me, it's looking like that's not going to work for us. So I'm thinking instead of 1 over tangent, what's an alternate way to write cotangent?
Sine over cosine.
Okay, now that's for tangent though, and we need cotangent.
Oh, there's a tangent. Sorry.
But you're close though, because cotangent is just the reciprocal. So all you need to do is just switch to the top and bottom.
Cosine over sine.
There you go, yep. So cosine of x over sine of x. And we can see that sine of x will cancel. And then that leaves us with cosine x equals cosine x. So we've shown that those are equal. Now I did say I was going to show you 2 different ways of solving it. The other way, it's not used. This one's not used as often, but it still works for us. what we could do is we could also divide both sides by sine of x. And this was kind of one of those where I said normally we try not to mess with both sides at the same time, but there's not really an official rule. So this would be fine if you wanted to do it this way as well. Then we're going to get cotangent of x equals, and then it would be cosine over sine. And you should be able to recognize that that is definitely equal to cotangent. So that's another way that we could have solved this too. There are other ways as well, but those two I think would be the two easiest ways of showing it. All good? Can I move on?
Yeah.
Yeah. Okay. So this one, oh, did I put these in the right order? I guess. Okay. All right. So this one, I want to see if you can prove that cosecant of theta divided by secant of theta is equal to cotangent of theta. I think I'll help you out a little bit with this. So rather than worrying about this fraction on the left side, I'm thinking let's do what we've done many times before with fractions when we're trying to divide by a fraction, which is we multiply by the reciprocal. So instead of what we have here on the left, I'm thinking, so normally on the left side, if we've got divide by secant, we're supposed to multiply by the reciprocal. So what is the reciprocal for secant?
Cosine?
Yeah, so that's cosine. So instead of dividing by secant, we can rewrite this by we can multiply with cosine. Then over on the left side, I'm going to take that cosecant and I'm going to rewrite that as well. And what is cosecant equal to?
Sine.
Yeah, so not just sine, but a little more specifically, what do we do with sine?
One over sine.
There we go. Oh, yeah. So we got 1 over sine of theta times cosine of theta equals cotangent of theta. So now that we have that over on the left side, you can see that if we were to simplify that, it is going to become cosine over sine. And therefore, we do get cotangent on both sides. Okay, if it's all right with everyone, I'm going to move on to the next one. So I talked about this when we did the Pythagorean identities, that some of these are, this is where it can be useful as well. So I'm looking at this one. Secant squared times 1 minus sine squared equals 1. And my recommendation for this is to think of our Pythagorean identities. So what is one Pythagorean identity from yesterday that you remember? So again, one of the formulas from yesterday. Does anybody remember one of the three?
Sine equals 1.
There you go. Yeah. So let's.
Oh, but squared.
Yeah, and we know that 1 squared is going to be just 1 anyway, so that's fine.
Yeah.
So sine squared plus cosine squared equals 1. Now, looking at the equation that we have here, I noticed that if we take this equation that I've written in green, we can rewrite that so that we can make a substitution. Specifically that if we subtract if we subtract sine squared from both sides, we can rewrite that into cosine squared of x equals 1 minus sine squared. So since we are able to do that, we can then take what was in parentheses over here, and we can just change that into cosine squared. So our equation can become secant squared of x times cosine squared of x equals 1. Okay, then what is secant squared equal to? And I'm not looking for the Pythagorean identity. I'm looking for what is the fraction that can be the same as secant.
One over sine? No.
It's
Wait.
1 over something, but it's not sine.
Cosine?
Cosine, there we go. Remember, secant doesn't have a co in it, so the thing that it's a reciprocal of must have the co. So we can turn secant squared into 1 over cosine squared. And that fraction then can multiply with cosine squared. Those are going to cancel. And we're left with 1 equals 1. And there we go. We proved that that equation must be true. Are there any questions so far with what we've done?
No.
Okay, I am going to move on then. So I want you all to try this one then. You shouldn't need to make multiple substitutions. I think if you use just one of the Pythagorean identities, that should be enough in order to solve this. So I'll give you maybe 2 or 3 minutes to work on it, and then I will show you how to get the answer. And then if any of you need any hints, just let me know in the chat and I'll type it there. Okay, so if anyone else needs a hint, then I just put one in the chat there. Actually, I guess 2 hints, but I'll give you all maybe about 30 more seconds or so for this. Okay, so my hint for you, you could honestly do it on both sides, or you could start on either side. But what I decided, I thought it would be easiest to focus on this right side, and I'm looking at that cosine squared, and I was thinking, let's use the same Pythagorean identity from before. Sorry, I can get all that. So I'm gonna bring this over. I'm gonna use this one again. And so my thought was, let's take that cosine squared over on the right side and turn it into 1 minus sine squared. So that would give us cotangent squared x minus cosine squared x equals cotangent squared. And then I'm going to take cosine squared and turn it into 1 minus sine squared. Now I'm going to take this cosine squared and I'm going to distribute that into the parentheses. So we'll get cotangent squared x minus cotangent times sine, cotangent squared times sine squared, excuse me. And the left side is still going to be the same. Now I can already see the cotangents here match, so that's good. I just need to now figure out how to turn cotangent squared sine squared into cosine squared. And cotangent is going to be cosine squared over sine squared. And then we can see that over on that right side, we do get the sine squared to cancel. And what is left is going to be what we were looking for. And there we go. That's it.
Well, where'd you get the minus cotangent squared?
Oh, because cotangent squared here is the same thing as cosine squared over sine squared.
What?
Wait, yeah,
Does that
how
make
did you
sense?
get that?
How did
Oh.
you get to the
I-
first one to the second one?
And Celine, was that you also asking that same thing?
It's the same thing, yeah.
Okay. So just as a reminder, cotangent is equal to cosine over sine. And then another thing is that if we were to square cotangent, then that's the same thing as this fraction on the right side squared. But what we do instead of keeping the square outside is we move it to be here. So like cotangent squared of x. So then that means that it's going to be the same thing as cosine squared over sine squared. So it's okay if this is still really confusing. The good news is that this is not a big part of this chapter. It's just mostly a little more practice than of just seeing the relationships between all of the trig ratios. Are there any other questions then with this problem?
Oh, I see. Okay.
All good?
Yeah.
Okay. All right. If everyone's okay, then I'm going to move on then. So the last two I was going to say might be getting a little trickier. So hopefully I don't go too fast for you. Please let me know if I need to slow down if I am going too fast. So I'm looking at this question, and I promise all of you, by the way, this would be maybe one of the harder to hardest ones you would ever see. Maybe extra credit, I don't know. But anyway, I noticed that over here on the left side, this fraction is divided by two things. And that's a bit of a problem for us. But I also notice that cosecant squared, well, that's going to be the reciprocal of one of our main three trig functions. Because what's the same thing as cosecant squared? Or in other words, one over what trig function
Sine
is equal?
squared?
Yeah, so that's going to be 1 over sine squared. So I'm going to rewrite the right side like that. This is, by the way, this is one of those equations where I think no matter what, we need to do something to both sides to solve it. We can't just focus on one side. Okay, over on the left side, we're going to keep that the same. Secant squared over secant squared minus 1. And what we're going to do is we're going to take the reciprocal of both sides. So I'm going to take the fraction on the left and switch the numerator and denominator. And I'm only allowed to do that if I make the fraction on the right side into its reciprocal as well. What should we have then on this left side when we simplify that? What does that become? And if it's easier, think of this then. What would happen if you made it into two fractions?
The two secants would cancel.
Yeah, exactly. Now we have to be careful. Make sure though that you're not just saying, "Oh, that's gone," and it's -1. But make sure that it's broken into two fractions first. But you're right. Then we can cancel those. So it'd be secant squared over secant squared minus 1 over secant squared equals sine squared. And then, yeah, Jade, I believe that was you who said that. We can cancel. Yeah, we can cancel both of those. So now for this first fraction, we're left with 1. What about 1 over secant squared? What is that equal to? If it helps, this one does not have a co in it. So whatever it's equal to must have a co in it. Any guesses from anybody?
Cosine squared.
There we go. Yeah. Cosine squared. Okay. And look at what we've got here. This is the result of the main Pythagorean identity that we've learned. Because normally it was, I'll do a different color here. Normally it's sine squared plus cosine squared equals 1. But if we happen to subtract cosine squared over, it turns into this down here at the bottom. So this is just the Pythagorean identity. And it turns out that both sides are equal to sine squared. So we have now proven that what we started with at the beginning had to be equal. Like I said, this was a question where we had to manipulate both sides in order to get the answer. Sometimes we prefer to only mess with one side, but this was one where we had to do something on both sides. Are there any questions then with how I was able to solve this one?
No.
No. And if you are feeling completely lost, if your head is spinning after this, don't worry. I'm well aware trigonometry is totally different from everything else we have ever done. So don't panic, don't be worried. Confusion is normal for this. So I'm going to move to the last one then. And I want all of you to try this. I am going to tell you, I encourage you to try to solve this the exact same way we did the previous one. So my hint right now, oh, I'm going to write that better. I got better handwriting than that. My hint for you is think of the reciprocals first. So do that to try to solve it, and then afterwards, then I can help you if you need some more help. Just let me know in the chat. Okay, I'll give you all about 1 more minute for this. All right, everybody. So my hint at the beginning was that you should be doing the reciprocal on both sides again. So over on the left side, that will be easy. We just switch the top and bottom. Tangent of x plus cotangent of x over secant of x sine of x. And then over on the right side, we know that we're going to get 1 over sine squared. And that right side then is going to become cosecant. Then for the left side, let's break that up into 2 fractions. We're going to get tangent over secant times sine. And then plus cotangent over secant times sine. Then I'm going to take pretty much everything and just turn them into fractions if possible. So tangent is sine over cosine. This one's going to get a little messy is what it seems like. Secant is 1 over cosine. And then we still got sine there. And then for the second one, cotangent is cosine over sine. And then we still are going to get 1 over cosine times sine. And that first fraction is going to turn out really nice for us. We have sine over cosine on top, but then notice how the bottom is also sine over cosine. So our first one is actually just going to cancel. Everything cancels there, and that is going to become 1. Then in the second one, we are going to have cosine over sine. Now the bottom was also sine over cosine, but if we are dividing by a fraction, we can multiply by its reciprocal. And we're going to get cosine squared over sine squared. That's going to become cotangent squared. And this is another one of our Pythagorean identities. So we end up getting cosecant squared on both sides. This one was really tricky, I'll admit that. I agree, Aiden. Or was that Adam?
What?
Which one of you did the sigh?
Oh, that was me.
Okay. So that was everything, and it is 2:50 now. So I will post the assignment onto both Schoology and I'll put it on Teams as well. I just want to make a note quick. The worksheet has, I think, 14 questions on it, but I'm only asking you to do 6. And when I post it, I'll make sure to include that those are the questions I'm assigning. So fortunately, everybody, this was the only day I was planning on doing, or I don't know, maybe it's a bad thing, but hopefully what we're doing tomorrow will be a little bit easier, not as stress inducing. So y'all can head out. Have a good day.
Thank you. Bye.
Peace.
Bye. You're welcome. See ya.